Three people with us here. They are each an awardee for the UAE Research Programme for Rain Enhancement Science. Let me first introduce Professor Hanneli Korhonen. She is from Finland. She's here to speak about her work on the role of atmospheric aerosols in efficient precipitation enhancement. I'm going to try and get to the bottom of that, but Hanneli, it's nice to meet you. Thanks for joining us. Let me just first of all congratulate you on being an awardee, and let me ask you for the reason that you are here, the decision behind taking part in the UAE Research Programme for Rain Enhancement Science. What attracted you? And also, if I can kind of further that and mix the two questions together, how does your proposal advance the science and technology of rain enhancement? If you can put that in simple terms. I know it's tough.
Okay, so the reason why we decided to apply in this program was that it actually funds also fundamental science, basic science, and not only technological advancements in the field of rain enhancement. And we have decades of experience in dealing with atmospheric aerosol particles. And what cloud seeding or rain enhancement is fundamentally is adding new particles into the atmosphere, and with the aim that they will impact cloud properties and also rain formation. And did you want to interrupt?
No, I'm just looking at it there because that's the best, I think, description of rain enhancement science that I've had today. I've been speaking to Alia Al-Mazrui. We'll hear from her later, who manages the UAE program. I feel like that summed that up really well. Thank you.
You're welcome.
Let's go to our second guest. Sally, I'll let you introduce Paul.
Yes, we're talking to Dr. Paul Lawson from the United States of America, and he's being awarded this for his work in investigating a new approach to rain enhancement that leverages ice production processes in cumulus clouds. Dr. Paul, congratulations, but what on earth does all of that mean?
Good question. I think I'll let Hanneli answer because she did so well on hers. Would you like to take that for me?
I mean, it sounds like it's got something to do with ice and, you know, therefore producing rain.
Well, that's true. That's true. See, we have, our company has a Learjet research aircraft with a suite of very advanced sensors on it. And we investigate the clouds and the microphysics in these clouds, looking at the little ice particles and water droplets. And we can tell whether this enhancement process has had any effect.
I mean, you know, it just sounds, like, you know, sci-fi. It's like something that, you know, you don't understand how it really works.
No, really. It's basic science. It's not sci-fi.
It's just,
and that's what we're trying to do, is understand the basic physics involved in clouds and how we can increase rain enhancement from them.
What made you kind of apply to be part of this program in the first place?
Okay, the UAE has a unique program here. This research program for rain enhancement science is unique in the world. It provides a significant amount of funding to do basic research. And other parts of the world are mainly just operational cloud seeding programs, but not a lot of knowledge involved.
I mean, particularly in this region, there are huge challenges in terms of bringing rain, you know, obviously producing rain and rain enhancement. And, of course, we've got Professor Giles Harrison here as well from the UK, who's always also, I beg your pardon, contributing to this. Professor Giles.
Congratulations, Giles. You're an awardee as well. Let me ask you about your work. I'm just going to read what's written here and try and get to the bottom of this. On the electrical properties of clouds, that's your work. And on rainfall modelling, your experimental work also includes making some of the first airborne measurements in UK airspace of the Icelandic volcanic ash, which introduced the flight ban, I guess, back in April 2010. Lots of us are aware of that. But talk me through how your proposal, if you can, once again in relatively simple terms, how will your proposal, with that in mind, advance the science and technology of rain enhancement?
Well, if you think about a cloud, and we just heard some descriptions of clouds, they've got lots of drops and lots of particles in them. And what our work is looking at is how to make the little drops stick to other little drops so we make bigger drops. Keep doing that and you get rain. So we're looking at using electric charge to do that. And if we can charge a drop we can make it stick better to the other drops around it. And that's what we're trying to do.
Can I ask you about the volcanic ash aspects of your research? Because lots of people will remember, and I guess at the time found it incredible that something as simple as volcanic ash could cause an aircraft splutter and in effect die out.
So the ash melts and gives you a sort of glassy coating inside the engine. It destroys the engine. That's not very good. It's not very economic.
Clearly not.
You don't want to be on the plane at the time either.
What made you decide to take part in the research program here in the Emirates?
Well, as the others have alluded to, this is fundamental science. What makes us tick, I think, is figuring out how the natural world works. And here's an opportunity to do it. And what's more, here's an opportunity to look if we can influence it as well for good humanitarian reasons. So very compelling.
3 of the awardees for the UAE research program for rain enhancement science. Dr. Paul Lawson from the United States. Dr. Paul, thank you very much. Nice to meet you. Congratulations once again.
Thank you.
And also Giles Harrison, Professor Giles Harrison from the University of Reading. Giles, it's been good to have you here. Thank you for talking to us. And also Professor Hanneli Korhonen from Finland. Her work on efficient precipitation enhancement and the I have to say, description of how rain enhancement science works has made it all worth it. It's been good to talk to you. Thank you.